Tangent 45 or tangent pi over 4, depending on your calculator mode, what should you get? Not 0.5. 1, right? You should get 1. So these are the 3 special cases. Got sound? I have. Okay, so these are the 3 special cases that I want you to remember first. Okay, ready? Okay, next, this is the exciting part. Okay, so can you do a sine 60 or a sine pi over 3? What do you get? Not a nice number, right? Okay, wait. Okay, sine 60. Okay, wait, why I cannot press the calculator? Sine 60 degree. You will get this string of numbers there, 0.86666. Very difficult to represent, right? So can you square this number? Can you square this number? What do you get? 3/4. So we don't like to represent in a non-terminating decimal. We like numbers, right? That are easy to represent. So actually, I know that the answer is square root 3 over 4. Because I squared it, right? So actually it came from square root 3 over 4. So you can remember it as root 3 over 2.
But how do we remember this?
You can use calculator lah.
But how do we know when to square it?
When the number is not nice, go and square it.
But will it always work?
Yes. Okay? So this is the one. So I hope you see, I hope you see the pattern. What about cosine 30? Yes. Can. Okay, cosine 30. What do you get?
0.866.
Which is the same as what we had just now, right? At the top where you do sine 60. So actually this is also root 3 over 2. Okay, so these two are the matching pairs. Later I want you to see the relationship between them. Yes. Yes. But you don't need to memorize. You can use calculator to help you. No need. Okay, but it's good to know the pattern so that you are quick in your solving.
Wait, but Miss Wong, why can't I just do the calc to
Yeah, you can. Just that you need to square it. So now can you try for sine 45 degree?
I find that it's easier to just use calc than remembering all of it.
Memorize also can. What about sine 45? But that number very difficult. So what should the cert be? Square root half, right? Which is 1 over root 2. Okay, which is 1 over root 2. Because when you get 0.707 and so on, when you go and square it, it gives you half. So that means your original number must be square root half. So go and repeat this same thing for cosine 45. You will realize it's the same thing. It's also this. So these two is a pair. Okay, I want you to see these two as a pair. Don't sleep in any lesson. Okay, what about tangent 30 degree? Give me the third answer. You can rationalize later.
I never sleep in any of my lessons.
Square it, you get 1/3, right? So when you square root, you'll be root 1 over root 3. My battery died. Talk too long.
I fell off my table.
My battery gave me up. Okay, what about tangent 60? 3? Not 3. What is this? Does it work like that? You help me? Square root 3. So like what I say, when you press tangent 60, right, it give you a string of number, go and square it. But your result is the square root of it. So with that being said, Can you find a relationship between these two numbers? They are both half, right? What about this?
Tangent theta equals sine over cosine.
They are both square root 3 over 2. What about this? They are 1 over root 2, right? Or if you go and rationalize it, it's root 2 over 2. Okay? What about the last one? It's a little bit different. I can see you, Shu Huai. Okay, they are reciprocal of each other. Okay, if you prefer this as the rationalized form, this is root 3 over 3. Okay, but any other thing you can observe about all this?
They're nice numbers.
Nope.
Compared to the.
Any other pattern?
No fraction.
Not about the result, about the angles.
They're simple, the same.
They are what?
13, 45, 15, it increases by 55, 16.
Increases by 15, okay. But is there a relationship?
They're all square root numbers.
No. They are all
In the second
complementary. What does complementary means?
enzyme substrate and
Adds up to 90. Okay, so they all adds up to 90. So remember, once you decide on one, you know the others. So how do I do it? First is sine. Okay, sine, take note, Shh. Sine, cosine, tangent. These are the few special angles that we are interested in only. So it's just 30, 45, and 60 because these are the common ones that we always use it as a quarter of our graphs. Okay, so sine 30, remember? So what is the first thing that I tell myself to remember is C6. Okay, C6 is the one that is 50% of your result. So that's why it's half. So once I've decided on my C6 being half, the complementary angle with 60 is 30, right? So sine 30 will be my half. Okay? These are the one that matches. These are the two that will give me the same ratio.
Why don't we use tangent?
Sorry? Okay. Then next one that will help me to remember is tangent 45 is 1. Yes. This one is the shortcut that I try to memorize myself. It has no mathematical meaning. So C6 is 50% of your marks. So cosine 60 degree is half. So that's how I remember my ratio. No, C6, the grade C6. Okay, so it's half. That's why my sine 30 is half because these two are complementary angles. Okay, then tangent 45 is 1. One of it is root 3. One of it is 1 over root 3, correct? So 30 being the smaller angle is the 1 over root 3. Then this is the root 3. So that's how I try to remember. Okay? Or if you want the rationalized form, this is root 3 divided by 3. Rationalize. If you go and rationalize it.
That's it, like the question.
Yeah, I don't catch your
Like draw the table in maybe like 30 seconds. Then
Okay.
if you don't really remember it,
Yes,
you don't know how to do it,
you
right?
can. Yes.
I remember watching a video and they said that we had to memorize the text.
You can memorize using another way. Yes. Because you will need to sub this into a fraction and your ultimate goal is to simplify it. So sometimes you need to rationalize. Okay. Then what about the others? Remember sine 45 and cosine 45. Okay, this one no choice. You have to remember this is the pair. So the equivalent rationalized form is this one. So that's, I settle the others, then I try to memorize the other pair. So this one will be the root 3 over 2. This one will also be the root 3 over 2. So you just need to remember these two are a pair. Okay, these two are a pair. Yeah, these two are a pair. And these are reciprocal of each other. Yes, Marius?
Sine and cosine, they have the same answers but different angles.
The angle must be complementary, then they have the same answer. Must add up to 90 degrees.
Remembering.
Yeah. Okay? So don't remember, never mind, because you can always use calculator. Cosine 30 degree, you get the answer, go and square it, and then the answer is the square root. You can do that, no need to memorize. But I'm just saying, if you memorize, it makes your life easier. Okay? So let's look at why you do this is because of questions like that. So they say don't use calculator. Imagine you give me this.
But how are they gonna know if he uses calculator?
If you write this, I know you use calculator lah. Right? I say don't use calculator, then you give me this. Obviously, you use calculator. So that's why you cannot show me that. You must be able to tell me that this is 1 over root 2.
Although technically you can use calculator,
You can, yes. So just use it intelligently. Sine 30 is the half, and then tangent 60 is the root 3.
I have a question.
Yes.
Let's say we write our working in pencil. Will they read it as using calculator, or will they just ignore all the pencil working?
They will still be able to see and circle. So, yeah. Calculator that you, method that you want us to mark, write in pen. Okay, so once you have this,
Isn't it 1 over square root?
what thing 1 over square root 2?
I thought cosine 45 is 1 over square root.
Yeah, but that is the rationalized form. So this one, what you can do to simplify the problem, probably I can times 2 for both numerator and denominator, so I can get rid of the fraction, right? Okay, so after I simplify, this is what I get. Then don't leave your answer like that, because final answer always need to rationalize, because this is certs. So rationalize your answer, so your chapter 3 comes into play now. Final answer should always rationalize. Yes.
The pi over 6 is 20 degrees.
Pi over 6 is 30 degrees, yes. Okay, a square minus b square. Sorry? 2. Okay, so final answer would be this. Okay? So the math behind it, if you use calculator, you will definitely give me a decimal answer, which we know is wrong. So I need the answer in certs, and this is impossible to get from the calculator value that you have. So we need to see that you can change. You can change, and then after that you can rationalize. So will they test you one individual question on certs? Maybe not. They will test it here. That means if I can see that you can rationalize here, I know you have the skill already. So I don't need to set one certs question.
Also, basically, they'll, instead of doing a search question, they'll
Yes,
do a,
correct. That's why certs needs to be learned first before you all can learn all this.
What if we do this without certs?
I'm
Nah.
not a
Then good
physics
luck to you.
student. I
Yes,
cannot
Mama,
do
you're so
graphs.
mean.
Okay, this one.
Use them.
Remember, this is tangent 30 degree. In my mind, I'm always operating in degree. So tangent 30 is the smaller one. That's why I got root 3 over 3, remember? Okay, then cosine, this is 45 degree. 45, I know is root 2 over 2. So if you memorize, it's fast. Okay? And then sine pi over 3, sine 60 degree. So this is the one with the root 3 over 2. Okay? So you do an expansion. Can. So the answer will just be this.
can't lie, right?
Okay, but if you never remember the rationalized form, you use this. You just need to work a bit harder.
Miss Wang,
Yes.
can you put like square root 6 minus 3 over 6?
Square minus 6. Minus 3 over 6. Yeah, can. You can combine into 1.
This is like wasting my memory space.
Okay? Christy, Alexa, and Yash,
Is mana better?
are y'all doing your work? Why y'all not sitting on your own chair but on one another's lap? Government give each of you one chair, but y'all want to share. Okay, what is tangent 45? Root 2 over... Oh, tangent... Sorry, wrong. 1. What is C6?
C6 half.
So what is sine 60?
Oh my god.
Sine 30 is half.
Square root.
Yes. Okay. So if you combine the fraction at the bottom, you get this, right? So 1 divided by this is to flip the fraction. So this is what you get. But denominator cannot have surds. You need to rationalize. So when you rationalize it, you multiply by 1 plus root 3. Because it's not simplified. So the bottom, 1 square minus root 3 square. Yes.
This one,
Yes.
for B, why can't you combine the two fractions?
You can. If you prefer, you just combine. But if you leave it alone, it is also fine. So, where's my working? Yeah. Okay, never mind. Things happens.
I agree.
Sometimes the life is time to slow.
So you just erased it.
Me? Did I? I was up there.
Yeah, you accidentally erased it.
Okay, I erase it. Okay, so if you divide, the negative, whether it's below or on top, you can always shift it. So the answer is just minus 1 minus root 3. It's as good as multiplying this by negative 1. It's the same.
You expand the 1 plus root 3.
Yeah. Yes. Okay, so this is a recap of your certs. This is a test of your memory. You can also remember them one by one. Okay, one by one. Your what? Your what?
I'm so done.
Okay, is this question common for O levels? Sometimes it is the first part of a question. Sometimes. What is sine 30 degree? This one is 30. Half. What is tangent 60 degree?
Cosine 30 is half.
Root 3.
Right. Cosine 60.
What is cosine 45 degrees? Shu I just took me. Okay, what is cosine 45? Root 2 over 2. So go and expand it out.
I paid attention. So I could get another cancel.
Can. Why not? Oh, actually I can just... Actually it's done, right? There's nothing to simplify. Nothing, no denominator to rationalize. So this is done. You can leave it like that.
Yay.
So
Okay.
you just change the
Or if you want to take out further 2, you can.
change the pi to 180, right?
Yes. Just like that. Also can. Okay, or if you don't like over 4, you can change this to over 4. Also can.
How did it become 1 over 4?
I take out the half some more.
Shouldn't it be...
This one is 1 ma.
You put the 2 above, right?
Below. I put the 2 above and below so I can take out the half.
Wait, isn't cosine 30.
1. Okay, and then remember tangent, the smaller one is 1 over root 3 or root 3 over 3. This one is the rationalized form. Okay, you choose which one you want to remember. And then the other one, tangent 60, is the reciprocal. So it's just root 3. So one is root 3, the bigger one, tangent 60 is root 3. The other tangent 30 is its reciprocal, 1 over root 3. Okay, then next thing you need to remember is the 60. So cosine 30 will be root 3 over 2. And then sine 60 will be root 3 over 2. So this is a pair. So remember which are the ones that are a pair. Okay, but in any case, if you ever forget, just press calculator cosine 30 degree. That decimal there, you go and square. When you square, they give you 3/4. So you know your original form is a square root of 3/4, which lands you with this. Okay, so calculator can still work, so don't have to worry about that. And then this one is 1 over root 2 each.
So what do you do?
You press calculator cosine 30 degree. It will give you a string of decimals. Go and square it.
I will read it.
Then you get 3/4, right? So when you get 3/4, the answer is square root 3/4. So just remember that. This one is the rationalized form. Okay? So this table will be helpful if you can remember. If you cannot remember, go back to the calculator. Okay, it will work perfectly fine. So I give you an example. Cosine 30. If you get 0.866 something, go and square it. And it will give you 3/4. So your original answer is actually without the square. Okay, without the square. So it should be square root of this. So that's why it's root 3 over 2. Okay, so calculator can help you skip the memorizing, but you must know how to use. Okay, anyway, now this question, it says that I have a triangle and P is the midpoint. Angle APC is 60 degrees and the length of AP is 10. So without using calculator, that word there, nobody is going to stand there and check whether you got to use calculator or not. They just don't want to see decimal answers in your working. That is just not mentally possible for you to calculate. Okay? So the word without using a calculator just requires your answer to be an exact form. Okay? They don't want to see decimals. Yes, can.
Who says it's impossible?
Okay, you can calculate. Can. Which one? This one.
Yes,
Okay.
thank
A
you.
to Z.
Thank you.
Do you get the end of your paper?
Yeah, just
Okay. Okay, so first thing first, I want to look at the small triangle. So I zoom. I want to look at the small triangle here to help myself find what is PC. So since it's a right angle triangle, I H, A and O. So I have H, I want to find A. So I will use cosine. So cosine of pi over 3. So it's PC over 10. So to find PC is just 10 times cosine pi over 3. But pi over 3 in my mind, I know is 60 degrees, which is the C6. So you know it's going to give you half. So actually PC is just 5 cm. So knowing this is 5, this will also be 5 because P is the midpoint. So now we'll focus on the big triangle. Okay, big triangle wants me to find the angle ABC. Oh, but I don't have enough info. I need at least 2 lengths of the big triangle. So I use the yellow triangle one more time and find O. Okay, I'm going to try finding O if I know H. So I'll use sine pi over 3. It's AC over 10. So AC is 10 times sine pi over 3. So you ask yourself, what is sine 60 degree? So if you cannot, press calculator, sine 60 degree. Then it will give you the 0.8 something. Go and square it, you get 3/4. So the original form is root 3 over 2. So that's what they need you to give. Give the exact, don't give the 0. The moment you put 0.866, gone. Your mark is gone because you use calculator. Okay, so this is the important part. So AC is just 5 root 3. Okay, so knowing this is 5 root 3, knowing the base is 10. Now we look at the big red triangle. So H, A, yeah. The lines are what? Okay, so HAO. So since the question involves tangent, right, this is what they want you to prove. You know you are using O and A. So tangent of the angle ABC is O divided by A. So 5 over root 3 divided by 10. So you will end up getting root 3 over 2. So they say, can you find the value of the integer k? So if you take an inverse of tangent, what is the k value if you compare with this?
I'm reminded again that this is A.
This is 3. So therefore k is just 3. Okay? So the solving process is still your tuakaso. Just that they need you to bring in the exact value. Like this one is half. Okay, and then this one, they need you to know the exact third form. That's the only difference. Okay? But not every angle has an exact third form. Some don't have. Okay? Okay, so this is like a 4 marks question.
You need to do it by comparison. It's K equals to.
If you want, you can write that statement to be very clear in your working. Okay, one more. Same thing, diagram, right angle, triangle. ABC is 30 degree, length of AB is 12. P is a point on BC such that BP is 2 times the length of CP. So if CP is 1 unit, BP is twice its length. So this is 2 unit. Okay, so the number that I circled tells me the proportion, not the actual length, just the proportion. Okay, so without using calculator, can you find the angle APC? So before I can start, I need to make sure I have this length. Without this length, I cannot move on. Okay, so first thing first, I need to refer to the big triangle now, because the info are all in the big triangle. So I refer to the big triangle. This one is 30 degree. This is 12. And then my mission is to find the other 2 lengths. So first, label your H, your adjacent side, your opposite. So let me first find what is BC. So to find BC, I have A and H. So cosine 30 degree, it's A over H. So BC over 12. So BC is 12 of cosine 30. So you go and press calculator of cosine 30. What should it be?
Wait, but I thought we can't use calculator.
Then you square it. Give me the third form. 3 over 4, right? So square root of 3 over 4 is root 3 over 2. Okay, if you memorize it, then you don't need to use calculator at this point lah. But you can always use calculator to double check. Okay, so this one is 6 root 3. So my BC is solved. The whole thing is 6 root 3. So if I divide it into 3 units, 1 unit is 2 root 3. The 2 unit here is 4 root 3. So if I were to split them into the 3 units. Okay, so I sort of know the length of CP already. Okay, next one is I need AC. This one. So to find O, I have H. I will use sine. Sine 30 is what I like. O over H. Okay, because sine 30 is a nice number. C6 match with sine 30, right? So this is half. So AC is just 6 cm. So I put it here, 6 cm. So they say without using a calculator, can you tell me what is the angle APC? So now we zoom into the small triangle, this one. So I redraw it. Okay, this is everything I know. So my mission is to find this angle. So again, bring in your hypotenuse, adjacent, and opposite. Of course, if you want to use sine rule, you can. Okay, so I have A, I have O, so I will use tangent. So tangent of the angle APC is opposite over adjacent. So if you simplify all, 3 over root 3. Okay. Cannot be. I think I must have done something wrong, right?
I got 3 over.
Cosine 6 divide by 3 units is 2, correct? Did I do something wrong?
I got the same answers.
Cause it's not a exact answer though. I should get a root 3 or a... Oh, yes. So if you rationalize it... Okay, no wonder I'm stuck. If you go and rationalize the cert... Where are my pencil out of battery? I don't think you can read my finger handwriting. What yes, what yes? Your yes blindly. Okay, never mind. You can always charge very fast, right? Okay, so if you rationalize it, you will end up having root 3. So when you take inverse of root 3, what is the angle APC? Which ratio gives you a root 3? 60. So the angle is just 60. Yes. How do I get what? Because the proportion, remember, they tell me BP is 2 times of sleeping. So this is 1 unit and this is 2. So the whole thing is 3 units. I divided this by 3 units. So this one is 2 root 3, this one is 4 root 3. Yeah, I proportion them out. Okay, if you have done this question using calculator strictly, right, you will end up with decimals here, and then you won't get a nice 60 here. Okay, that's the downside. Because tangent 60 degrees is root 3. Remember your special angle? This is the only one that gives you root 3, the 60 degree. But of course, you can go and use your calculator. Tangent inverse root 3, you'll get 60 degree. Okay, so please, you can use calculator, but use it intelligently. Don't show that you are using calculator.
After this, will we do chapter 11?
No. Yeah, Yeah, you tangent inverse. You tangent inverse root 3. You will get 60. Square root 3 is 60 degree. No, tangent 60 degrees gives you root 3. Yeah. It's because of this. So I know this is 60 degree. Yeah. How did I get what? They give? Yeah.
How do you know your tangent inverse search 3 is 60?
If you memorize the table here, you know tangent 60 is root 3 ma. So if you inverse it, the angle is 60 degree. Yeah. So go and come up with a card, try to remember it. But if you don't want to remember it, can also use calculator. Anyway, there's only 3 angles to play with, 30, 45, 60. Okay? Can. Okay, the next section, right, is the type that you will see in your exam.
They remove this without using calculator, they use some side.
Yeah, can. Yeah. So it can be in any form, but the most typical type of question that will appear in your exam is the questions you see on page 7, 8. 7 and 8. Yeah, why? All this we use, this one we use degree because the angle is in degree. Yeah. Okay, so now let's look at how this can be related to your XY grid. Okay? Grid, yes.
Since the question never specifies
The question here is 30 degrees, so we will leave it in degree. Yeah. Keep the whole question consistent. Okay, this one. Okay, take note. It says that my theta is an acute angle. So you know that your drawing is within the first quadrant. Because acute angle is less than 90 degree. Okay? So 2/3 meaning this is 2, your O is 2, and then your H is 3. In its simplest form, it could be a 4 and a 6, but in its simplest form is 2 and 3. So to find A, we use Pythagoras theorem. So 3 square minus 2 square square root. So it's a square root 5. Okay, so that's the first step. Get your triangle out. Get all the 3 sides known to you. Then now question say, can you then find what is cosine theta? So part 1, cosine theta would be A over H. So root 5 over 3. Okay? Okay, part 2, we want to find tangent theta, which is O over A. So O over A. Okay, we usually don't leave your answer with a cert in the denominator. So just go and rationalize it. So you should get 2 root 5, 5 as the final answer. Okay, next is the part 3. What if I change to the other angle? 90 minus theta. So you ask yourself, 90 minus theta must be this other angle here. Okay, so if you change your angle, your adjacent and opposite side will change. So you must label it accordingly now. Hypotenuse, adjacent, opposite. So when you change the angle you are referring to, your hypotenuse, adjacent and opposite must change accordingly. Yes.
How do you know that value?
Because they want 90 minus theta. This is 90 already, right? The other 2 angle must add up to 90 also. So if this is the theta, this is the 90 minus theta. Okay, again, this is 90 already. So it tells me that these two must be 90 also. Okay, and since this is theta, what is this? Yeah, so that's why when they say 90 minus theta, they are referring to the other acute angle. Same quadrant, same triangle, just that refer to the other angle.
So if we say 90 minus theta, it's just look for the angle that doesn't have.
Yes, the other one, the other acute. Okay, so sine theta now is O over H, but refer to the blue labels. So your blue labels O over H is root 5 over 3. Okay, it's still within the same triangle, just that your labels have changed. Last one, tangent 90 minus theta. It is O over 8. So refer to the blue labels. O is root 5. A is 2. Okay, we might as well also find cosine 90 minus theta, which is A over H.
Oh, why did you put number 6 instead of 5?
5. Okay? So, just take note that whatever triangle they give you, after you draw the right angle triangle, then you can go and calculate the sine, cosine, tangent ratio. Yes. Yes, until we go to the next quadrant, then we start the ASTC. Now it's still first quadrant. Yes. Yeah.
Am I right for this? Yes, right.
Which one? Sine 2tan is here, 30 degree. So but AS, yeah, positive one. Shouldn't it be? Second quadrant.
STC, because it's minus.
CAS. Second quadrant is S is positive.
Oh.
So it's sine 30. Okay? Can Okay, so now they want you to find some form of relationship. Is there a relationship between sine 90 minus theta, this one, and cosine theta? Can you see they are equal actually? Okay, so they are equal. So that's why they write here, they are the same. They will give you the same ratio. It will help you skip steps. That means you don't need to go and relabel. If I ask you for sine 90 minus theta, you can straight away give me your cosine theta value. You don't even need to go and draw your new labels. Okay, so if you know this complementary relationship, you can reduce some effort. Not saying that it's a must to know. Okay, next one is they ask you for the relationship between tan 90 minus theta and tangent theta. So if you look carefully, between these two, what is the relationship? Can you see they are reciprocal of each other?
Yes.
It's like you just flip it, right? So that's why this is the relationship they write here. Okay, the reverse is also true. That means I can write tan theta here and then 1 over tan 90 minus theta. This is also true. Okay? So last one is why I ask you to calculate this is because I want you to be able to see that cosine 90 minus theta will be the same as sine theta as well. Okay, so that's why they write it here. So these are the three relationships. So which is why we can say that when we memorize the complementary angles, right, we say that cosine 60 is same as sine 30. They are both half. Okay, remember that? And then we also know that when cosine is 30, no, the other one, let me see. Same, yeah, 30. Then sine 60, both are root 3 over 2. They are equal basically, as long as these two angles sums up to 90. Yes. Good to know because it helps you skip steps. Yeah. If you never memorize this or you don't remember this, then you will have to end up doing the long way, but which is fine also. Okay. So now, what if they give you everything in algebraic form, which is possible? And if you look at your last year, end of year paper, this was the question that was tested for end of year. Okay, so this was also one of the year O-level question. So cosine theta, first they say it's acute. So straight away you know it appears in your first quadrant already because it's acute. So I draw the theta out, I draw my right angle triangle. Okay, next is they say cosine theta is k. K and k over 1 is the same thing. So they are telling you that A is k and H is 1. Okay, in its simplest form. So go and label, this is H, A and O. So A is k and H is 1. So how to find O? We use Pythagoras theorem. So 1 square minus k square square root. So the simplified form is just like this. So this is your length of O. So to find sine theta, no problem. Just do your O over H.
Everything's in like.
Yes. So just that everything is in algebraic form. So tangent is O over A. Okay, and then lastly, the more complicated one is to put everything together. So my cosine theta, I know it's k. My sine theta, I know it's 1 over square root 1 minus k square. And then my tangent 90 minus theta. Just now we know, right? Instead of reducing your problem, this is the same as tangent 1 over tangent theta. Okay, 1 over tangent theta. So I just have to replace this with my 1 over tangent theta value. So if I flip this, I will get this. So if you know, it makes things simpler. But if you don't know, you just have to go and label again. Right? Label again. Find your H, A, and O. And then realize that your O over A is K over this. Also okay. Just that a bit more tedious only. Okay, so if you simplify the problem, it is just 1. Okay, so since they mentioned that your end of year only test up to this 10.1, right? Likely it will be questions that are like that or on the page before that. Okay, because I think solving is in 10.2. So you will not be required to solve. It's all in terms of triangle. So just which quadrant we are talking about. So if it goes obtuse, if it goes to the third quadrant or the fourth quadrant like your reflex angle, then we will have to find reference angle. Okay, so the next activity is to find reference angle. If you all go to your Google Classroom, you will see that I just posted a basic angle HTML. Okay, so now okay, just some theory behind when we measure angle, right? We always start from 0 here, and then we start turning, right? So if we move in an anti-clockwise manner, our angles are all positive. So that means starting from 0, okay, put this here. That means starting from 0, right? This is here 0. When I increase my angle, all this angle from maybe 20, 30 until 90, then 180, 270, 360 is all positive.
This is for the AFTC that
Correct.
angle.
Correct. So this one important. If I'm talking about 220 degree, I'm referring to starting from here, turn until you point to 210 degree here. Okay, it is a anti-clockwise direction. But if you decide to move in the clockwise manner, we are talking about negative angles. So that means if I say negative 150 degree, I'm starting from 0 also, but go negative 150 is here. So if it is negative, it is going in clockwise manner. So clockwise is clockwise direction, it's a negative angle representation. Okay, positive angle, it's anti-clockwise. Oh, I wrote here. Okay, positive. Negative, clockwise. Okay, so that means if I go in this direction, let's say minus 150. Okay, if I go in this direction, let's say 350 degree. Okay, so note the difference. It depends on what we get. Okay, then next thing that I'm going to talk about is super important is what we call the reference angle. Okay, no matter what we are doing, remember no matter which quadrant you are in, right, we must always go back to the right angle triangle is formed. So if I go second quadrant, my angle so big, right? I still have to go back to the right angle triangle here. Yes. So this one, third one, even if I go into the third quadrant, in order for me to find the right angle triangle, I'm only referring to this angle. Okay, this angle, and then the very last one, even in the fourth quadrant, if my angle is 330, okay, which ends here, I will still be referring to this angle here. Okay, can. Okay, so in the fourth quadrant, no matter whether your angle is acute, obtuse, or reflex, right? We will ensure that the right angle triangle form is always with respect to the x-axis. This is number one rule. Okay, your right angle triangle, can you see, is always, the base of the triangle is always with the x-axis. And then that angle that you see, right, like the tiny fish I showed there, right, it is called your basic or reference angle. This basic or reference angle has no sign attached to it. It is always acute. Okay, it's always acute. Just that which quadrant does it lie in only. So this one lies in the first quadrant. This one lies in the second. This one lies in the third. And this one is in the fourth quadrant. So no matter where it goes, we are always looking at the reference angle only. So let's look at this first one. You look at the next page, there are plenty of angle that I'm asking you, right? What is the reference angle? So first thing first, 50 degree. So if I were to do a sketch for 50 degree, it's quite apparent that it's just like that. Right, just 50 degree. And then my reference angle is just the angle that is given. So it's the same angle. So I can also call this to be 50. When you use this symbol, the one that looks like a fish, okay, it is with reference to your reference angle or basic angle. Okay, what about this one? Yes.
The reference angle is the one
in the triangle. So if I go 100, it's here, right? Somewhere here. But the reference angle I want to find is the angle that is made with the horizontal line. So what is the reference angle here? 80 degree, right? So how to get it? We use 180 minus 180 minus the theta that you have. This is the angle they give you. Okay, in this case, my reference angle is just my given angle. This one is in the first quadrant. Okay, what if we go the third one? 170. Can you see that 170 is here? What is my basic? Just 10. Yes. Theta is the angle that your minute hand or your hour hand is moving. 100 degree. The angle that is formed.
So 2 pi minus 7 pi over 4. Is it?
Wait. I'm teaching halfway. You ask me random question. Yes. Can. Yes.
So theta the angle outside the right angle.
Theta is the angle that my arm has originally moved. I cannot just say that it's always outside, but okay, if you want to interpret outside, yes, can. Okay, 185 will go into another area already, beyond my second quadrant. So it will move into your third quadrant. So if you look carefully, I've said 2 sentences, I must charge my pencil one time. Because it's running on 0. Okay, 185. Somewhere here. So my theta is 185, but what is my basic angle here? Just 5. Because it's 180 plus the plus basic, yes. Yeah. My pencil cannot charge like that. My pencil must charge by contact. Okay? So what I'm saying is this is okay, can you this one is 5. Okay, this one is this one is the 10. Yes. Sorry? The acute is just your reference angle because it's in the first quadrant. It doesn't go anywhere else. Okay, 360 will go to the fourth quadrant. So you go until 340 here, right? So 340 is your theta. Reference angle is just this part, 20. Okay, but even if we go negative direction, it's okay because it just means that we are going this direction, negative 7 degree. Negative 70 degree, right? We are going clockwise, 70 degree in that first quadrant, okay? But what is my basic angle? It's the same, but you drop the negative because acute don't have negative one. We ignore the sign. So this is 70, yes. Angles can't be negative, can? If you go into another dimension. E-math, we don't have negative angle. A-math, now we are in a different zone. Okay, we are in a different zone. You upgrade your driving license, you can drive to more places in a more dangerous way. Okay, so G would be 150 in the clockwise direction. So go until here. Right, minus 50 go into the second quadrant. So what is your basic angle here? Basic angle don't care about direction, right? I just want to know what is the angle in the right angle triangle. 30. Okay? So can you try yourself for HIJ? Just a quick one. Wait, I label, I charging my pencil. Okay, this one 30. Yeah, they ask you to sketch. So you can just sketch it. This one is for G. C. This one is B. B is A. Yeah. Opposite direction, the clockwise one. Start from the same line but go clockwise. Okay? Minus 300. You will go into the fourth quadrant in the opposite direction here. So the basic angle is still 60. Basic angle don't care about your sign. Okay, they don't care about your sign. 500 go second revolution already, second round. So doesn't matter, even if it's second round, don't be scared. So 360, one full round already. So continue to press on another 140 degree until here. So 500 degree is like this, right? So actually I know that this tiny part here is an extra 140. So what is the basic angle? Just 40. Yes. Part what? Part F. Okay, if I go in the negative direction, here is 0, right? I go in the negative direction 70 degree. So this is negative 70 degree. So my basic angle is still 70. Because this is the right angle triangle, same. They are the same.
Why is it not?
Basic angle don't care about the angle positive or negative. They only look at the absolute value. The magnitude of the, yes. Yes. I 500 one more time. You go one full circle is 360 already. Not enough. I need to move until 500, right? So another 140. Another 140 here. So this is my basic angle, which is 180 minus the 140. The first round that is done, I don't need to care about it already. Yes. Got people call me. Okay.
So if the terminal angle is in the second, it's
180, yes, correct. So now we are here, right? Just to emphasize, okay, one last one, J. Minus 420. So you go opposite direction. One full circle is minus 360. You need to press on for another, how many degree? 360, another 60. So another 60 here. So you get minus 420. So this is your reference angle, another 60 degree that you press on to the first quadrant. Okay? So here it's 60, right? Yes. For D, is it 185? Yeah, correct. Okay, so anything in the first quadrant, the basic angle is the angle. Okay, anything in the second quadrant, this basic angle is always 180, take away your theta. So that's why they write here. Ayo, die again. The maximum what? Oh, okay. Cannot go beyond that, is it? Okay, can. Should be okay. Because we never go beyond that, right? In this example. Yes, yes.
For all four quadrants, right? Let's say cosine negative theta, will it be a cosine positive theta?
Yes. For the fourth quadrant only. Part I and J. Okay, 300. One full circle, I don't care. 360, I don't care. Because one full circle, I haven't have a landing point in any quadrant yet. So you ask yourself, beyond the 360, I still have another 140 degree to cover. So another 140 to cover, it will land myself finally here. That means my arm, turn one full 360 already, still must carry on 140 to cover 500 degree. So this 140 is the landing point, but what I'm interested in finding is what is this basic angle. So still go back to the same thing. This one will be 180 minus the 140, which is 40 degree. Okay, So same thing, minus 420, same thing. If you ignore the minus, right, 360 is one full cycle. So 420 minus the 360, there's still 60 degree that I have not covered. Okay, so if I go negative direction, minus 360, done. I still need to cover another 60 degree in this direction. Okay, so my landing point is in this quadrant with a 60 degree here. So my basic angle is just the 60. Yes. For the negative one, reference angle, don't care about the sign. Only look at the magnitude of that triangle in that triangle that you form. Okay, so this is a summary. If you are in the first quadrant, your basic angle is just the angle that is given. Okay, in your second quadrant, your basic angle, you always use 180 minus your given angle. And then if you are in the third quadrant, to find your basic angle is always whatever angle they give you minus away the 180. Okay, or if you can tell me it's 180 plus. No. It's your reference angle minus 180 degree. Okay, then the last one, to find this, it will be 360 minus your reference angle. So these are the 4 quadrants. What will happen and what is it that you need to do? Okay, so when you go home, you can play around with the applet.